Section 9.1 is our first section that introduces confidence intervals, which is a huge application in statistics. And it's a way of describing a region on a number line where we think the population parameter will fall. Now, what we've done before is look at the statistics, and the ones that we're going to look at with confidence intervals are the sample mean and the sample proportion. Just to remind you, the sample mean was when we added up all the data values together and then divided by the number of data values. That sample mean would be a point estimate for the population mean. For the proportion, if we take the sample proportion, which is at relative frequency, so in other words, you ask a question, you count how many people respond yes, you then divide that number by the total number of people that you asked. That gives you the sample proportion. This sample proportion will be a point estimate for the population proportion. Once we have that point estimate, we want to put a region around this point estimate, and this full region is called our confidence interval. Now, the distance from the middle of your confidence interval, so let me just draw a quick picture. Here's a number line. We'll say, okay, this is where the middle of our confidence interval will be, and then we'll make a region around here, and it's symmetric on both sides, so I'll try to get them to be the same size on both sides. That whole region, so this would be your lower limit, this would be your upper limit. This distance here is called your margin of error. That is what I called it. And you have that on both sides. So like this distance on the right is the same as this distance on the left. That distance is called the margin of error. Right in the middle, this is the point estimate. Now, the size of this confidence interval, or really the size of the margin of error, is controlled by something that you actually choose, which is called the confidence level. This one here. This is called the something you choose. A very standard choice for the confidence level is 95%. That's the most common confidence level that we're going to use. You can use other confidence levels. A lot of times it depends on the field of study, and in a course like research methods, they would tell you what the standard is to use in the specific field of study that you're working in. But for the most part, we're going to use 95% as our confidence level. Now, there's something else that's in here, kind of in the background for us, because we're going to use technology in order to get these confidence intervals. But it's called the critical value. And I just want to go through a quick example of how to get the critical values. In this class, we're going to use technology for the confidence intervals, so you don't necessarily need to get this critical value. And it would use like a lookup table either way. So there's not really an easy way to get the critical value. It's so embedded in technology that I have my students just use the technology So yeah, I put here critical values can be calculated using the inverse normal distribution, and in our confidence interval Excel file, we're actually going to have it embedded in that file as well. So this one says find the 95% critical value. So just looking back up to here, whenever you see this Z, that's the standard normal distribution. So we already know that our mean is going to be 0, our standard deviation is going to be 1. And then with the confidence level that they're giving us there, the 95%, we want to find those values. So let me just draw a quick picture here. It's centered at 0. And we're finding two values so that this area in between is 95%. Then you put it in decimal form. Okay, so the way to denote this, this would be the positive Z, and I'm just going to put 0.95, subscript it with the probability, and this one over here on the opposite side of 0, negative Z, 0.95. Okay, now I just want to write here what we're going to do. We're going to use the inverse normal. Distribution Excel file. And we're going to put in the parameters. The mean is 0. The standard deviation is 1. This is just because it's the standard normal. And our probability that we plug in is 0.95. And we're going to plug that into the center option. Just put that here. Okay, once we plug those in, it will give us this value. But let me show you this, and I have to download this one. Make this a little bit bigger. And we're using this one over here, the center option. Mean is 0, standard deviation is 1, 0.95. We get 1.96 just about. But there are some more decimal places here. But this one here, you use the positive one to answer the question. So that's just about 1.96 here. Okay. Let me go back. There it goes. If you wanted to find other critical values, typically you're just going to look onto the confidence interval Excel file because it's going to be in there. But you could also use the inverse normal. You would just change this 95 to whatever confidence level that they give you in the problem, and it would just change this input right here. Okay, I think that's the last time we're going to use that one. Now, with confidence intervals, I'm going to have these like sheets that they're usually like one page, and they're going to list a lot of things that you don't necessarily need to memorize. Mainly because I want you to use technology in order to get these confidence intervals. It's a bit outdated to do these things by hand. You certainly can do them by hand, but you don't need to do them by hand in my class. And in general, if you're working in statistics, you wouldn't do this stuff by hand. You would use technology in order to get these different values. Now, I have each of the different confidence interval instructions on single pages. So you just really have to pay close attention to like which one you're using. So like this is for the proportion, and that will change for each of the sets of instructions. Now, each set of instructions split into 3 different steps. The first step is to check the conditions, which I have listed here. This is something that you should get in the habit of doing. Sometimes our conditions aren't going to be met, and we'll say just ignore that they're met or note that they weren't met and that the results that you get may not be accurate. But we'll check these 3 conditions, which we had in Chapter 8. The random sampling criterion, which doesn't change from one to another. The normal criterion, which does change from one situation to another. So you have to be careful to use the correct normal criterion. And then the last one usually doesn't change from one to another. It's called the independent sampling criterion, which we talked about in Chapter 8. Once the conditions are met, you do the computation, and if you ever have a stats teacher that makes you do it by hand, I have it here as reference. Hopefully you won't ever have to do them by hand because it's a little bit tedious, but just in case you do, they're listed there. In my class, I want you to use Excel. So the Excel file is confidence intervals Excel file. And one thing I'll show you, make sure you navigate to the proportion sheet at the bottom. Super important, a very common mistake. You need to make sure you can navigate the Excel file. And then once we have the computation, like here, this is our lower limit and our upper limit. That's typically what you report with a confidence interval. We can interpret it. And you have to be a little careful with the interpretation. There's a lot of different ways to misinterpret a confidence interval. But if you use this statement here, this is a good interpretation of a confidence interval. Okay, so let's go through this example, give you an idea of how I want you to solve these types of problems. And this one says a large dormitory has 10,000 students who select their either a vegetarian meal or a non-vegetarian meal. A random sample of 188 students at this large dormitory cafeteria area showed that 66 chose the vegetarian option as their meal plan, and we'll let P represent the proportion of students selecting the vegetarian option as their meal plan, and we're going to find a 90% confidence interval for this proportion. Now, the first thing I like to do is just to ground ourselves in the point estimate, so what's in the center, and to do that, we'll look at the sample proportion. So the sample proportion is P hat, that's the symbol we use for that one, and it's 66 out of 188. You can compute that, just do division, 66 divided by 188. We get about 35%. I'm going to put some more decimal places just so we have them. Okay, so about 35% choose that vegetarian meal plan. Now, we want to be 90% confident, so we have to run a confidence interval. So the first step in this, and I'm just going back up to here, I need to check these conditions. Okay, so I'm just going to right here, check conditions, just so I know what I'm doing. The first one, it says random sample, so that's good. That means a random sample was used. So I'm just going to write that. And check it off. The second one, we're checking up here, this formula. Perhaps a good idea to start memorizing those. And we're taking that 188 times this thing up here, what I calculated before. Times 1 minus that whole thing. Be very careful with the parentheses. Let me just add in multiplication symbol here. Be careful with the parentheses. They're critical. And when you plug that in the calculator, you get about 42, actually about 43, 42.8, which is definitely greater than 10, which is good. That's exactly what we needed for this condition. And because of this, just going to put an arrow here. We'll say the sampling distribution is approximately normal. And this is good news. That means we can use the normal distribution as an estimate of that binomial distribution, and then also use that normal distribution in constructing our confidence interval. Okay, the last condition is the independent sampling, and it has this condition, so n is less than 0.05 times the capital N, the population size. And our sample size was 188. So just filling that in. We're checking, put a question mark there, is it less than 0.05 times, gotta look for, oh, they did give us a population size. So the large dormitory, 10,000 students, that 10,000 is that capital N. It's the population, the size of the population that we're pulling from. So we multiply those together. I'm just gonna move this over here. This gives us 188 is less than 500, which is true. That's awesome news. The sample size isn't too big to lose independent sampling. And so we can say the sample is independent, or sampling is independent. Okay, all three conditions were met, so we're good to go. So I'll just draw a line here. Now, You could do this by hand. I do not want you to do it by hand. If you ever think that you're going to need to do it by hand, you can certainly practice using the formulas up here, and then you can double check that you did this formula correctly by using the Excel file. But I really do just want you to use the Excel file for this. It makes it quicker to do the calculation and a little bit more accurate because it keeps all the decimal places. So it's a good idea to use this Excel file. So I'm just going to write here, this is our compute step. And our computations will be done with technology. So I'm going to put here, use the confidence interval Excel file. I will likely abbreviate that CI in the future, just so you know. And then we're going to select the proportion sheet. And I just put this is at the bottom. And I'll say this a lot in the last third of this class, let the Excel file guide you. Once you're on the correct sheet, it will have a list of a bunch of different things that you need to fill in. Okay, here it is. And here's what it looks like. The sheets that I was talking about are down here. And you can see we're going to go through 5 different situations in this class. There are definitely other situations, but we're not going to cover them in this class, so I just limited what I put in here. But we're using this one here, which is a proportion. And there's 3 things for us to fill in. So I'm just going to copy this down, p hat. These 3 things. This, fill in the stuff that's gray, don't fill in the stuff that's not gray, so don't touch those. Those are calculations. You can kind of see them here. They're being calculated. Also, those are calculated. So we need p hat, we need the confidence level. Usually abbreviate that with C, and then the sample size is N. Okay, so I'll go back to here. After I copy down those, I just need to identify what they are. P hat was something that we actually calculated already. That's 66, and then out of 188. I'm just going to do the division in Excel so I don't lose decimal places. The confidence level given in the problem, right here, the 90%, so 0.9. And our sample size was 188. Okay, now we plug those in. It will then give us our lower limit, which I'll abbreviate LL, and our upper limit, which I'll abbreviate UL. Let me show you what happens when we do that. Okay, so here equals, do 66/188, press enter, 90% confidence, and 188. Once we have those 3 things plugged in, it calculates for us, and we get our lower limit, 0.2938. Usually they'll round to 4 or 5 decimal places in the homework. Just follow the instructions that they give you. And then the upper limit, 0.408322646. Okay, so now the last part, we have to interpret what's going on. And you can use as a reference what we have up here. And I'm just going to say, maybe even like use this language here. We can say that we are 90% confident that between, and actually let me go back. Let me word this just a different way. So we can say that we're 90% confident that the population proportion of students who choose the vegetarian meal plan at this dormitory is between, I'm going to rate it as percentages just because I like communicating with percentages versus the decimal. 29.38. I guess we could say about 29.38% and 40.83%. So it gives you a range of values that we think the actual population proportion is at. So it's not as exact as the estimate. It gives kind of a range of values of possible values that we feel fairly confident about saying our population proportion is within. Okay, cool. So that's our first confidence interval. I know it may seem like a lot of steps, and it can be challenging. The hardest part usually for students is not really the steps and getting the numbers. It's more of deciding which situation you're in. So like you read this problem, you have to know that this is looking for a proportion. And then the interpretation is usually a little bit tricky. But the computation usually isn't the hard part, which is kind of nice with this last third of the class. Okay, so I talked about interpreting the confidence interval. So I just wanted to more clearly define how to interpret. It's very easy to misinterpret a confidence interval. So I put a fill-in interpretation here. I'm not particularly fond of fill-in interpretations because it is more of like you're memorizing versus understanding what's going on. But some students do prefer this, so I place this here just in case you would want to memorize an interpretation. It may help you if you prefer memorizing things. So here I have an example, and I put the answers here as well. It says a 90% confidence interval for the mean weight of full-grown Pomeranians was calculated to be 3.3 to 6.6 pounds. And this is a really typical way of writing a confidence interval. It's just a range of values. So 3.3 to 6.6 is what that stands for. The lower limit is 3.3. The upper limit is 6.6. And it says right conclusions about this confidence interval. A good interpretation here, we are 90% confident that the mean weight of all Pomeranians is between 3.3 pounds and 6.6 pounds. Notice here all Pomeranians, and it's the mean weight of all. So just note that. That's describing that population mean, the population mean of all Pomeranians. And then the second one, not quite as important, but I like to include it. Some statisticians prefer this interpretation, or having an interpretation of the confidence level. I am okay if you just have these first two lines here, the first sentence. So at the interpretation of the confidence level, if you take out several samples of the same size from the population randomly and create confidence intervals, 90% of the confidence intervals will contain the true population mean weight of Pomeranians. One thing with this, I think that makes errors a little bit clearer. If you read this or interpret this in a different way, 10% will not contain the population mean weight. So there's always a chance that your confidence interval doesn't actually contain that population mean. So always keep that in mind. A confidence interval is a great estimate, but it can be wrong. So here's one bad interpretation. It says 90% of Pomeranians have weights between 3.3 pounds and 6.6 pounds. This, unfortunately, is a really common misinterpretation of a confidence interval. The problem with this is that it doesn't reference the word mean at all. It's applying to specific Pomeranians, and that's just not true. So let me just read here. This is bad. Since it's applying to individual Pomeranians. Super common misinterpretation. Just be very careful with that. Don't write in a conclusion of an academic paper once you get a confidence interval that it applies to individual things in your study. It applies to the population mean. So just be very, very, very careful with that. This one is a less common misinterpretation, but still is a fairly common misinterpretation. It's applying to samples instead of the population parameter. So let me just write a quick sentence here. It's applying to samples, which is bad. You don't want to do that. Okay, we'll do one last example, and then we'll do the last page in our next video. So this one says a researcher randomly sampled customers about their preference of milk or dark chocolate and created a confidence interval for the proportion who prefer milk chocolate, going from 61.5% to 72.3%. That one right there. Now it's asking what is the point estimate, the sample proportion in this case. Now you really have to think about how the confidence interval is constructed. This is our lower limit, this is our upper limit. Right in the middle of those two values will be our point estimate, And for the proportion, our point estimate is the sample proportion. So you want to find the halfway point between the two. And in order to do that, you add them together. And divide by 2. And when we do that, make sure like this would be in parentheses if you're doing it in a calculator. It gives us 0.669 or 66.9%. Now, this one says, this part B, it says, what's the maximal margin of error? We want to find the distance from the center to one of the edges. So you kind of think about this. I was just saying 0.669. It's right in the middle. 0.723 and 0.615. So we want to find one of these distances. And there's lots of different ways to do it. You can either like subtract these two or these two, or you could even do like this one minus this one, divide by 2. I usually like using the one on the right. So do 0.723 minus 0.669, and it gives us 0.054, which is the same as 5.4%.